Scene script: have you ever imagined a sky with two suns? What if one of them was Jupiter? Picture this giant gas planet, brimming with hydrogen and helium, transforming into a blazing star. Stars, like our sun, form from vast clouds of gas and dust, collapsing under their own gravity until their cores ignite. Currently, Jupiter is far from this fiery fate, existing as a massive gas giant, the largest in our solar system. Now, let's dive deeper into what Jupiter is really made of. Jupiter, a behemoth in our solar system, but what exactly is it made of? Diving into the gaseous envelope that surrounds this colossal planet, we find that Jupiter is predominantly made of hydrogen and helium, the same basic ingredients that make up our sun. This composition places Jupiter in a category similar to stars, yet it dances on the edge of that definition without fully crossing over. In addition to hydrogen and helium, Jupiter's atmosphere contains traces of water vapor, ammonia, methane, and silicon-based compounds. These elements contribute to the vivid color palette of its swirling clouds, painting a picture of dynamic complexity. One of Jupiter's most striking features is the Great Red Spot, a gigantic storm larger than Earth itself. This mammoth cyclone has been churning through Jupiter's atmosphere for at least 300 years, yet its exact depth remains a mystery. This enduring storm symbolizes the turbulent and mysterious nature of Jupiter. Understanding its composition brings us closer to the star question. But how does Jupiter compare to real stars? Diving into Jupiter is like exploring an alien world of extreme conditions. Picture this: a realm where the simple act of existing is a challenge due to unimaginable pressures and temperatures. Within this colossal gas giant, the pressure is so intense that it could crush a submarine as effortlessly as you might crush a soda can. Delving deeper, Jupiter's core, or what we theorize to be the core, is a swirling, mysterious place where hydrogen behaves in ways unfamiliar to us on Earth. Under such extreme pressures and temperatures, hydrogen exists not as a gas nor a liquid, but as a metallic substance. This metallic hydrogen is crucial as it conducts electricity and creates Jupiter's massive magnetic field, one of the strongest in our solar system. The temperatures here soar to around 24,000 degrees Fahrenheit, rivaling the conditions found in the sun itself. These conditions provoke a question that tickles the imagination. With such intense internal conditions, could Jupiter ever tip into becoming a star? From a gas giant to a star, what's missing in Jupiter's cosmic recipe? The leap from planet to star might sound like a fantasy, but it's grounded in astrophysics. Let's delve into the celestial mechanics of how a giant like Jupiter could potentially light up the cosmos. At the heart of every star, including our own sun, lies the process of nuclear fusion. This stellar phenomenon occurs when immense pressure and temperature force atoms to fuse together, releasing vast amounts of energy in the form of light and heat. For a planet like Jupiter to embark on this transformative journey, it would require a critical ingredient: mass. Jupiter, while massive by planetary standards, holds only about 1,000th the mass of the Sun. To kickstart nuclear fusion, it would need to be about 75 times more massive than it currently is. That's a lot of extra hydrogen and helium. If, hypothetically, Jupiter began to accumulate more mass, drawing in comets, asteroids, and even other planets, it might reach a point where its core could sustain nuclear fusion. However, even then, it would likely become a brown dwarf rather than a full-fledged star. Brown dwarfs are failed stars that start the fusion process but can't sustain it, primarily burning deuterium, a heavy isotope of hydrogen instead of regular hydrogen. So, if not a star, what could Jupiter become if conditions were tweaked? The answer lies in a delicate balance of mass and cosmic chance, keeping Jupiter fascinating but firmly within the realm of gas giants. Let's explore a fascinating what if: Jupiter as a brown dwarf. Brown dwarfs are celestial objects that are too massive to be planets, and yet not massive enough to sustain nuclear fusion at their cores like true stars. They are, in a way, the universe's almost stars, lurking in the shadows between planets and stars. Now imagine if Jupiter, the colossal giant of our solar system, kept accumulating mass. It would need to gather additional mass roughly 13 to 80 times its current size to make the leap into brown dwarf territory. Such a transformation would not only change Jupiter itself, but would also send ripples across the entire solar system. The gravitational ballet that keeps our planets in harmonious orbits might turn chaotic. Earth and other planets could experience dramatic shifts in their orbits, potentially leading to drastic changes in climate and even the stability of life itself. While Jupiter as a brown dwarf is intriguing, the reality is starkly different. A new star in our solar system would rewrite the rules of our cosmic neighborhood. Imagine Jupiter, not just as a planet, but as a star, casting its own radiant glow across our solar system. This transformation would not just be a spectacle, but a cataclysmic shift in the delicate dance of celestial mechanics. The very fabric of our solar system's architecture would be altered. Planetary orbits, long stabilized by the sun's gravitational pull, could find themselves tugged in new directions by Jupiter's increased mass and luminosity. Earth, along with its neighboring planets, might experience dramatic changes in their orbital paths, potentially leading to severe climatic shifts on our home planet. Moreover, the introduction of a second star would amplify the solar radiation enveloping Earth. This could lead to increased temperatures, disrupting ecosystems and weather patterns globally. The night sky, once a tapestry of predictable celestial events, could become a dynamic canvas of change. The balance of our solar system hinges on each planet, especially giants like Jupiter. Jupiter, as we've seen, is more than just another planet. It's a colossal gas giant, primarily composed of hydrogen and helium, with an atmosphere featuring the iconic red and white bands that capture our imaginations. Inside, it's a maelstrom of extreme temperatures and pressures, conditions that tested the mettle of the Galileo probe and shaped our understanding of planetary science. Despite its star-like qualities and composition, Jupiter lacks the critical mass required to initiate nuclear fusion, the process that powers stars. If Jupiter were to gather more mass, it might become a brown dwarf, a sort of failed star. But even this scenario remains a stretch of the cosmic imagination. The theoretical transformation of Jupiter into a star would lead to catastrophic changes within our solar system. The balance we observe today, from the orbits of planets to the conditions that permit life on Earth, owes much to Jupiter's current mass and position. So while Jupiter isn't on track to becoming a star, its role in our solar system is no less stellar. Our journey through the cosmic possibilities of Jupiter concludes. What an exhilarating voyage across the potential and the profound implications of our giant neighbor. If you've enjoyed this exploration, show your support by liking and sharing this video. Your engagement fuels our journey into the unknown. Don't hesitate to leave your thoughts and questions in the comments below. And for those who thirst for more celestial wonders, subscribe to our channel. Keep your eyes on the stars, and who knows what mysteries we'll uncover next.